So last day, I recalled or brushed off of your head, the cobwebs off of your head. I said, Pythagoras, a squared plus b squared equals c squared. And we talked about sine and cosine and tangent. And we learned last day that your calculator has all the values for sine and cosine and tangent built in. You can either give it an angle and ask it to give you the decimal value of the sine or the cosine or the tangent that goes with it, or you can give it the sine or the cosine or the tangent as a decimal, and by hitting your shift button, reverse engineer it and go back to the angle. Remember that, Karn? Let's put it all together. We defined sine. We said that sine is actually the opposite side over the hypotenuse. The length of the opposite divided by the length of the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. Tangent is the opposite side divided by the adjacent. We have this nonsense word acronym that we use called Sohcahtoa. That's worth having up here. Or what I always did whenever I was teaching trig is anytime I turned the page in my homework, I wrote Sohcahtoa at the top of the page. It took 1 second. It ingrained it in my memory, and it was like my free body diagram of trig, something I just did all the time as a habit. Putting it all together, example 6 says determine the length of the indicated side to the nearest 0.1 meters. Let me zoom in so that McKenna can see okay. First of all, can I use Pythagoras for this? Why not? You're right. No. Pythagoras only works if I have two sides. How many sides do I know here? One side and an angle. I'm going to use right-angled trig, or what we often call Sohcahtoa. Which angle did they give me, Noah? Which angle did they give me? Read it to me. Color, 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 color. I always do that because I've written something down, I feel better, and now I know which angle I'm looking at. I'm going to label the sides. Do you notice that one of the sides is completely blank right now, the top one? Leave it blank. There are some teachers who teach you to label all three sides. I think that's bad teaching, and you'll see why in a second. This x, opposite, adjacent, or hypotenuse. Put a little O there. That 15, opposite, adjacent, or, well, I guess adjacent or hypotenuse. Put a little H there. Carter, do you see why I leave the top side blank? Because to me right now, it's obvious I'm going to use the trig function with the O and the H. If I label that, I've done extra writing to make the diagram more confusing. That's double yuck to me. Which trig function has the O and the H in it? So let's write down sine. What always goes next to the trig function? The angle. I'm going to say that again. What always goes next to the trig function? The angle. Wes, what always goes next to the trig function? Allie, what always goes next to the trig function? What always goes next to the trig function, Aiden? Remember that. Trust me. What's my angle this time, Noah? Do you see why I see going full circle? What's the angle this time? You told us about 2 minutes ago. Okay? And that equals opposite over hypotenuse. But I'm not going to write the O. I'm not going to write the H. Instead, what is the O on my triangle? X? Yes? What is the H on my triangle? How would I get the X by itself? Next time Aiden will sharpen his pencil before I start teaching. I told you I'd catch you on these things. How would I get the X by itself? By what? So, no, is it multiply? You might as well say, do some math. More specific. Multiply 15 over. So, X is going to be 15 times the sine of 57. In our notes, we're going to write all these steps, and then as we get good, I'll show you where I think you can cut corners, Mark, if you want. Type that into your calculator. On my calculator, I go 15. I don't have to hit times. I can actually press sign, and I'm lazy enough that I experimented with it and said, oh, I can save myself a whole keystroke. 57. My calculator opens up a bracket, but I've also learned I don't need to close off the bracket, and I'm lazy enough that I can save myself a whole keystroke. I got 12.5800. Okay. How many sig figs are we going to go to? This year, 3 sig figs unless the question says different. So 12.6. Oh, is that right? No, yes? Okay. Some built-in error checks. The hypotenuse is the longest side, so I know it's got to be less than 15. If I got an answer bigger than 15, I'd have an issue. Noah, did that work okay, or you got the wrong answer? Okay, I'll come look at yours in just a second. Let me write down the answer. X equals 12.6 units, centimeters. If you did not get that, now is your chance to raise your hand, and I'll come around and look at it. B. Color, 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 color. And again, it's dumb, but I've learned just by doing that, for some reason, my brain gets the sides mixed up far less often than if I don't. The 11.1, opposite, adjacent, or hypotenuse. The X. I know that's the hypotenuse. I'll leave it blank. I got an O and an A. Which trig function? What always goes next to the trig function? What's the angle this time? And that's going to equal opposite over adjacent. If you do a bunch of trig questions, you'll find they end up falling into 2 main categories. The x's on the top or the x's on the bottom. Where is the x here? On the, look up. If you want to, you can write this down, or you can just imagine it. Can you see how that's technically a fraction? Which means this is 1 fraction equals 1 fraction. Who remembers the shortcut from last day? Stuff can move diagonally. The x can move to there. The tan 28 moves to there. X equals 11.1 divided by tan 28. By the way, assuming this triangle is roughly to scale, does the x side look bigger or smaller than the 11.1? That's also a bit of a hint. You'll get a bigger answer. So 11.1 divided by tan 28. If you were just, you get 20.87, 20.9. If, Josh, you were in a rush and you went 11.1 times tan 28, maybe because you thought, oh, I always multiply, I hope you'd realize, I don't think that side is 5.9 long. I think it's longer. So 20.9, yes? Units, centimeters. So this is not Pythagoras. There was somebody here last day who started trying to do these questions with Pythagoras. Yes, I know there's 3 things, but Pythagoras doesn't work for this. It only works when you have 2 sides, find the third missing side. Sohcahtoa, when you have 1 angle and 1 side. Or when you want to find an angle. So here, Karin, do you notice they gave me 2 sides? I could find the third side length using Pythagoras, but they didn't ask that. They want me to find the measure of the angle. Can you see where the angle is? Color, 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 color. That 15, opposite, adjacent, or hypotenuse. Give me 1 second. Sorry, that 15, opposite, adjacent, or hypotenuse. Yep, put a little h there. That 7, adjacent. Leave the other one blank, don't confuse yourself. which trig function? Sorry, cosine. Cos. What always goes next to the trig function? Everybody? What's the angle this time? X. What's that going to equal? Adjacent over hypotenuse. Oh, now we're finding an angle. How do I do that? This was using the shift or the inverse or the second function button. Although, because I've got a fraction, what I'll have to do is go second function cosine bracket 7 divided by 15. Or those of you that have the fancy smancy fraction button can use that there. But you need to let it know that you want it to go 7 divided by 15 first, and then shift cos that. And I get 62.181860. 62 degrees. I usually go to the nearest degree. 62.2 if you really want to be meticulous. So there's a symbol for angle. Look up. The abbrev for angle, amazingly, is an angle. X equals 62.2 degrees. The abbrev for angle is kind of a capital letter L that's slanty. B. B. Josh, what variable do they want me to solve for in B? Because I asked you to. What variable do they want me to solve for in B? Come on, you've missed that joke. It's been almost a whole year. It's been a while. Why? Because I asked you to. Why? I agree. So Josh, color. That 8.1, opposite, adjacent, or hypotenuse? 14.5. Ooh, I got to think. Oh, okay, yeah. What's the 14.5? H. Good. Which trig function? Sine? What always goes next to the trig function? The angle, which in this case is the letter y. And that's going to equal opposite over hypotenuse. Shift sine bracket 8.1 divided by 14.5. So this must have come from a 33.96. I guess if I round off, 34.0 actually, I think. Yes? Degree angle. The diagrams you'll get will be roughly to scale. In other words, if I found, oh, let me pause for a second. Back. Two terms. It's called attention span back here. Two terms, angle of elevation and angle of depression. These are terms that will show up in physics word problems, and you're often going to get these mixed up. You have to be very, very careful. The first one kids are good with. Angle of elevation that's the angle of elevation from the ground up. Or what we say is you raise your eyes. If you imagine yourself standing in the picture, and if to see the angle you have to lift your eyes up to go through the angle, that's an angle of elevation. Okay? Compare that with angle of depression. An angle of depression, if you're standing on top of a cliff, so you're right here, this is the angle of depression. You lower your eyes. there's going to be a bit of a problem here. You'll often have a question where they've given you the angle of depression, but they want you to solve that triangle. And the problem here is this angle is not in that triangle. Or is it? What's your suggestion, Carter? Mark? Here? Where have you seen that, the Z? Do you remember which teacher? Do you remember which teacher? Okay. So did you do foundations of math or pre-calc? You did both. See, what you're talking about is technically called alternate interior angles, and yes, there is a Z there. The problem is in pre-calculus, they do almost no geometry. You saw that in FOM, probably. And unfortunately, I can't assume you've seen that. So the easiest way is this. This angle right here forms a big 90. And I think, Carter, this is what you were trying to hint. If that's 20 degrees, how big is this red angle here? 70. If that's 18 degrees, this is 72. So the key is there's going to be a couple of questions in your homework where I say blah, 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 and I use the phrase angle of depression. Make sure you look back at this diagram. That's the angle that I gave you. A whole bunch of you will want to put the angle right there. It's not that angle. It's 90 minus that angle that goes there. So we have angle of elevation versus angle of depression. So we reviewed quadratic equations last day, and you either learned how to use your quadratic solver or you learned how to do it the long way. We reviewed formula manipulation. Hopefully that was old hat to you. I can't remember how to do that. So in the homework, you can try number 1. If you can do number 1 all on your calculator without showing any work and go straight to the answer, answers are at the back. I'm good with that. Number 2 and number 3, I don't know why I have 2 2s there. That's all calculator work there, so you shouldn't need to show any work. 4 is good. Probably need to show at least 1 line of work, but you can certainly show 2 if you wish. 5 is good. You can show 1 line. 6 is good. Then we have some word problems. I am going to skip one of these. I got to remember which one. 7 is good. No, I like 8. Oh, I must have removed the one that I didn't like. And then quadratic equations, 9, A, B, C, D are good. And 10, A, B, C, D are good. So we're easing into it a little bit. And for the formula manipulation, the first 2 equations should be familiar to you. The last 2 equations are orbital mechanics. That's a preview of coming attractions.